Hello everyone, I'm Shaoli Zhang and we're pleased to have the class with you. Today we'll talk about the hematopoiesis. We all know that there are three basic questions about life. That's who am I, where am I from, and where am I going? Accordingly, there are also three questions about blood. That's what is blood? Where does blood come from? What's the function of blood? Blood is a fluid tissue composed of plasma and blood cells that circulating in cardiovascular system. It accounts for 7 to 8% of body weight. Blood plasma makes up about 55% of total blood volume. Plasma itself is around 90% water, with 10% remainder including proteins, minerals, waste products, clotting factors, hormone, and immunoglobulins. Let's see where blood comes from. In developing embryos, blood formation occurs in aggregates of blood cells in the yolk sac, called blood island. As development progresses, blood formation occurs in the spleen, liver, and lymph nodes. When bone marrow develops, it eventually assumes the task of forming most of the blood cells for the entire organism. However, maturation, activation, and some proliferation of lymphoid cells occurs in the spleen, thymus, and lymph nodes. In children, hematopoiesis occurs in the marrow of the long bones, such as the femur and the tibia. In adults, it occurs mainly in the pelvis, cranium, vertebrae, and sternum. Let's see the process of hematopoiesis. Hematopoiesis starts from hematopoietic stem cells. These cells have unique abilities of long-term or even lifelong self-renewal and multilineage differentiation. HSCS give rise to common myeloid progenitors and common lymphoid progenitors. Myeloid progenitors can differentiate into megakaryocyte, erythrocyte, mast cell, granulocyte. The megakaryocyte finally releases cytoplasmic fragments called platelets. The granulocyte includes neutrophils, eosinophil, basophil, and monocyte. Lymphoid progenitor can differentiate into NK cells, T lymphocyte, and B lymphocyte. B lymphocyte can further differentiate into plasma cells. Blood cells basically include white blood cells, red blood cells, and platelets. RBC has the longest survival period. It can last for 120 days, while WBC can survive for only 3 to 4 days. Platelets can survive for 7 to 14 days, but only be inactive for 2 days. RBCs are biconcave discs that has no nucleus. This structure enables RBC to have plastic deformation. RBCs are made up of hemoglobin, lipids, ATP, carbonic anhydrase, etc. The main function of RBC is to transport oxygen from lungs to tissues and CO2 from tissue to lungs. So in case of anemia, the people will feel fatigue. In case of anemia, the organs with decreased oxygen supply will give a signal to kidney. Then the kidney will produce more erythropoietin. The erythropoietin acts on the bone marrow, and the bone marrow produces more RBC. Thus, the organs will get more oxygen supply. Platelet is actually not a cell. It is a cytoplasmic fragment of megakaryocyte. It is filled with granules involved in blood clotting, such as serotonin, calcium, and ATP, etc. Although platelet is very small, it plays an important role in blood clotting. It has adhesion, release reaction, aggregation function, which are important in the coagulation process. Let's see how platelet works. If the blood vessel is broken, the exposed collagen binds and activates the platelets. The activated platelets release platelet factors. which attract more platelets. The platelets aggregate into a plug and stop the bleeding. WBC can be divided into two categories, including granulocyte and agranulocyte. Granulocyte contain many granules, including neutrophil, eosinophil, basophil. The agranulocyte includes lymphocyte and monocyte. Basophil takes up 0 to 1% of total WBC. It is spherical-shaped. The nucleus separates into lobules and is lightly dyed. Basophil contains basophilic granules and dyed into bluish purple. The granules contain heparins and histamine. Eosinophil account for 0.5 to 3% of total number of WBC. It is spherical-shaped and has two lobed nucleus. Eosinophil contains granules that stain with ethane, a red acidic dye. They increase in allergic responses and engulf substances that triggers allergies. Neutrophilic granulocyte, or neutrophil, takes up to 50 to 70% of total number of WBC. It has multi-shaped nucleus, some like bent stick or separated lobules. The more lobules it has, the older it is. Cytoplasm is dyed into pink, containing many small fine light purple granules. They are phagocytes that accumulate at the site of infection, where they digest and destroy bacteria. Monocyte takes up 3 to 8% of total WBC. It is the largest cell among WBC, which is round or oval-shaped. The nucleus is oval, kidney, horseshoe, or other irregular-shaped. Monocytes are the precursors of phagocytes, which have an important role in fighting disease. They move from the bloodstream into tissues and dispose of dead and dying cells and other tissue debris by phagocytosis. Lymphocytes account for 25 to 40% of total number of WBC. It is round or oval-shaped, including natural killer cells, T cells, and B cells. Lymphocytes are made in lymph nodes and thymus and circulating both in the bloodstream and the lymphatic system. Lymphocytes play an important role in the immune responses that protect the body against infection. They can directly attack foreign matters and in addition make antibodies which neutralize and can lead to the destruction of foreign antigens. There's a mean induction of blood. Next time, we'll talk about one known malignant myeloid disease called myelodysplastic syndrome.